Okay, so let's start solving the NEET 2022 paper. It's just come out. So the first question is the graph which shows the variation of de Broglie wavelength of a particle associated with momentum. So we know what the formula is. Lambda is equal to h upon p. So h is a constant. So if I want lambda as my y-axis and momentum on my x-axis, then it is comparable to y is inversely proportional to x. Right? So inverse graph should be number 4. So that's this one. Then second one, as the temperature increases, the electrical resistance increases for both conductors and semiconductors. We know that conductors have positive alpha and semiconductors have negative alpha. That means with increase in temperature, the resistance is going to decrease for semiconductors. So this one is wrong. Decrease for both is wrong. Increase for conductors, yes, and decrease for semiconductors, yes. So this should be the right one. Decrease for conductors is again wrong. So fourth one is not the answer. Okay, so the third one, let T1, T2 be the energy of an electron in the first and second excited state of hydrogen atom. So please understand T1 will now correspond to first excited state is the second orbit, and T2 will correspond to the third orbit, the second excited state. So according to the Bohr's model of an atom, the ratio of T1 by T2. What is T, by the way? It is the energy. So don't get confused with time period. This is energy. So we know energy formula is minus 13.6 EV into Z square by N square. So basically Z is the same. So I'm going to get inversely proportional to N square. So I'm going to get T1 by T2 is going to be N2 by N1. This is 1 and 2, right? Squared, so N2 is 3 and this is 2, so squared means 9 by 4 should be my answer. That's this one. So the fourth one now, two objects of mass 10 kg, 20 kg respectively are connected to the two ends of a rigid rod of length 10 meters. So I have a rod 10 meters, I have object 1 10 kg, object 2 20 kg, and this rod is massless. Now the distance of the center of mass of the system from the 10 kg mass, so obviously I'm going to use XCM, is M1 X1. So let's consider this as my axis. So M1 10 kilos, X1 is at the origin, M2 20 kilos, X2 is at the length, and the length they have told me is 10 meters, right? So 10 divided by M1 plus M2, so that is 10 plus 20. So I get 0 plus 20 into 10 upon 20 plus 10 is 30. So I get 20 by 3 meters. Okay. Then they want the ratio of the distances traveled by a free falling body in the first, second, third, and the fourth second. This is Galileo's law. So it should be 1, 3, 5, 7. Right? So this one. So the next one is the ratio of the radius of gyration of a thin uniform disk about an axis passing through its center and normal to its plane. So let me draw a diagram. So just draw it here. So this is my disk. This is the axis passing through center and normal to the plane. So they want the ratio of for radius of gyration about this axis to the radius of gyration of the disk about its diameter. So diameter would be this one. So this is axis number 1, this is axis number 2. Okay, so space here. Right, so the radius of gyration formula I is mk square, or k is basically square root of I by m. So mass is anyways a constant for both of them. So what I need to do is get a ratio of the moment of inertia about first the main axis of the disk and second is the diameter. Okay, so I can now say k is going to be proportional to root of I. So k1 by k2, if I want, it's root of I1 by I2. So what I really need to do is get I2. So since it's the diameter, I will use the perpendicular axis theorem. I will say Ix plus Iy or Id plus Id, because both of them are diameters, is Iz for a disk, right? They've said it's a disk. Yeah, thin uniform disk. So it's going to be m r square by 2. So this will give me Id, right, which is in this case my I2 diameter, is going to be mr square by 4. So that's it. K1 by K2 is going to be root of I1 by I2. I1 is mr square by 2 and I2 is mr square by 4. So I get root 2. So root 2 is to 1, should be this one. Okay, then the next one, the angular speed of a flywheel, which we again consider flywheel like a disk. So angular speed of a disk moving with uniform angular acceleration. All right. So flywheel is a disk. So uniform angular acceleration is telling me that alpha value, right, alpha is constant, or basically it is telling me it's a uniformly accelerated non-uniform motion. So I will use the kinematical equation. So angular speed, that is should be omega, but what they have given here is frequency. So frequency changes from 1200 to 3120 rpm. So we can convert it to hertz in 16 seconds. So the angular acceleration of this is a very simple one. So what I can do here is, okay, so they are telling me f1 is 1200 per minute. So if I divide it by 60 again, right, 6 to the 12, so 20 hertz, and f2 is how much they said, 3120 per minute again. So 30 hertz, and then again the time they have told me is how much, 16 seconds. So what is required is the alpha value, right, angular acceleration rate. So the alpha value is going to be omega 2 minus omega 1 by t. So 2 pi f2 minus f1 by t, and if we solve this, we will get 2 pi, and t is 16, f2 minus f1, so 52 minus 20, 32. So 16 to the 2 to the 4 pi. Yeah, that's what they are giving, 4 pi. So that's this one. So the next one is ideal gas undergoes 4 different processes from the same initial state as shown. So they're giving me PV curve, and they're giving me 1, 2, 3, 4 curves. These processes are adiabatic, isothermal, isobaric, and isochoric. So the curve which represents the adiabatic process. So obviously adiabatic has to be a curve. So it's either the second or the third one. But if you compare with a isothermal process, then adiabatic process has a steeper curve. So of the two, the steeper curve is this one, second one. Okay. So that should be the answer. Okay, so going ahead, next one is two hollow conducting spheres. So they are hollow and they are conducting, means they are made up of metal of radii R1 and R2 have equal charges. Okay, so R1 is very large compared to R2. So the potential would be what? So what's the formula for potential? Formula for potential is V 1 upon 4 pi epsilon naught. Right? Potential is Q by R. So Q by on the surface, right, would be capital R. So now the charge is the same, they have said. Right? Equal charges means Q is constant. 1 upon 4 pi epsilon naught is definitely a constant. So V here is inversely proportional to the radius. So the potential would be what then? So if R1 is very large, if the denominator is very high, then the V value is very small. So it's more on the bigger sphere? No. It's more on the smaller sphere? Yes. Equal on both? No. Depend on the material. So obviously I will go with it's more on the smaller sphere. Okay. When light propagates through a material medium of relative permittivity epsilon r and relative permeability mu r, the velocity v is given by what? So we have a direct formula, that is v is basically 1 upon root of mu epsilon. So not epsilon naught, it's epsilon. So what they want is they want the answer in terms of c. There is c here, obviously it's not c. So what we could do is we can write this mu as mu r into mu naught, epsilon as epsilon naught into k, the dielectric constant. And now this term here, 1 upon root of mu naught epsilon naught, this is c. So I have c upon root of mu r into k. Or sorry, instead of k, they are using epsilon r. Right? So generally we use k, but the symbol they are using in the question is epsilon r. So that's okay. So is there an option like this? Yes. So there is this one. Okay. Right. So the next one now, they are saying that a long solenoid of radius 1 millimeter has 100 turns per millimeter. So what have they given me? They have given me the value of number of turns per unit length. It's 100 turns per millimeter. So that's 10 raised to minus 3 meter. So that turns out to be 3 plus 2, 5 turns per meter. Right. So it's a solenoid. So 1 ampere current is given to us, and the magnetic field strength at the center of the solenoid. Obviously, this is a very simple one. It's mu 0 and I. So I have the answer they want in terms of, not in terms of mu naught. So we should substitute 4 pi 10 raised to minus 7 into n value is 10 raised to 5 and I value is simply 1. So I have 4 pi into 10 raised to this will be minus 2. Okay, so 4 pi, so 3.14, so 4 3s are 12 point something, so there is only one option here, 12.56, and obviously the power should be 10 raised to minus 2, so we got this one. Okay, next one is the peak voltage of AC source, right, is equal to the value of the voltage supplied RMS of the AC, no, peak and RMS are root 2 times the, yeah, so it should be either of this. So we know that the RMS, ERMS, is E naught by root 2. So the peak is going to be root 2 times the RMS. Okay. So root 2 times the RMS value. So that is this one. Okay. So the next one here is there is a lift, an electric lift with a maximum load of 2000 kg. Lift plus passengers is 2000 kg. Is moving up with a constant speed. It's not accelerated. So we have the value of V is 1.5 meters per second. Constant speed means it is dynamic equilibrium, or in other words, I have to use DST, distance speed time. So the frictional force opposing the motion is 3000 newtons. So the minimum power delivered by the motor to the lift in watts is 1. So let's draw a simple FBD. So the lift is moving up. Okay? So there is a force, let's say F, which is pulling the lift up, and there is an opposing force. Obviously, the applied force. Actually, since they are in the lift is in equilibrium, they need to be equal. So there is an opposing force of, let's say 3000. Yes, 3000 newtons. Okay, and obviously there is also mg. And how much is mg? 2000 kg. So 2000 kg into g, and the value of g they have clearly mentioned to us as 10. So I will say 2000 into g is 20,000. So 20,000 plus 3, 23,000 newtons downward force we have, and the lift is going up with a constant speed. That means the upward force Summation F is 0. Dynamic equilibrium means summation F is 0. So the upward force F is going to be the downward force, which is 23,020 plus 3, so 23,000 newtons. Okay, so this is the force, and they are asking us the power value. So the power is simply going to be force into velocity, so that is 23,000 into 1.5. So basically it's like 1.5 times of 23,000. So half of 23 would be 10, 11.5. So it's 23 plus 10,000 plus 3,000 ka adha is 1,500. So that's it. This should be the answer. 34,500. Yes, that's this one. Okay. The next one, they're talking about YDSE. In YDSE, a student observes 8 fringes in a certain segment of screen when the monochromatic light, so the number of fringes, let's just call it as N, is 8. Monochromatic light is 600 nanometers. So let's call this as N1. And if the wavelength is changed to 400, okay, so number of waves he would observe. Oh, very simple. We have N1 lambda 1 is N2 lambda 2. So N2 is going to be N1 lambda 1 by lambda 2. N1 is nothing but 8. Lambda 1 is 600. Lambda 2 is 400. So I have 4 2s are 6 2s are 12. Okay. Now the next one here seems to be slightly twisted. Copper wire has a length. So they've given us the length. Radius so many meters. So this seems to be the radius of cross section. Right? Resistance of 10 ohms. Fine. Current density. They are asking current density, and as you can see in the units, it's ampere per meter square. That means they are asking J. J, which is I by N or I by A. Right? Current upon area. And electric field strength of 10 volts per meter. So that is our E. Okay. So let's start with resistance because there is no direct relationship here. So let's begin with what we know. Okay. So we can start with, we know R is rho L by A. We also know R is V by I. Now using the relationship between electric field intensity and potential, right? Field intensity is we can say Q by R square and potential is Q by R. So if I multiply the field, which is E, into distance, that will give me V. So this V can be written as E, and the electric field is over a distance L. So I can say the distance here is L. So this L and L gets cancelled off. So what I am left with now is what I want is I by A, right? I by A, which is nothing but J. This is what is required, right? Is E by rho. But the thing is, we don't know rho. E is given to us, right? Value of E is given to us. So this rho now we can again replace from here as rho is nothing but R A by L. So that will go in the numerator. And this area is nothing but pi into radius square. So that's it. Now all of these numbers are given to me. So E value is 10 volts per meter. Length is 10. The resistance is 10. E L by R pi, and square of this, so 10 raised to radius square, so 10 raised to minus 2 square is 10 raised to minus 4 upon, which goes in the numerator, root of pi squared would be pi. So when the pi is gone, 10 is gone, and I'm left with 10 raised to 5. That is this one. So it turned out to be quite easy actually. Alright, so the next one is again is not a usual one. So we have been asked the dimensions m raised to 1, L raised to 1, T raised to minus 2, ampere, that's current raised to minus 2, belong to what? Belongs to what? Okay. So fine, we usually don't memorize the dimension. So what we can do is we can begin with what we know, right? What do we know? We know this. So mass raised to 1 means it is kg. length, I'm just writing the units. Length raised to 1 is meter. Time raised to minus 2, matlab in the denominator will be second square, and this is ampere square or current square. Right? Just ampere square. Okay. Now this, if you pay attention to this, a meter per second square is nothing but meters per second square is acceleration. Let me write A. And kg is nothing but for mass, so ma, and m into a is force, and this is ampere square means it is current square. So now do I have a formula where I have force and current square? Definitely I can say F force per unit length between the force experience of attraction or repulsion between two wires carrying current parallel, kept parallel to each other, right? So there is a formula F by L rather is mu 0 I1 I2. Let's say I1 is equal to I2, so I square by 2 pi A, or let's just say proportional here, remove the constants 2 pi, and this is distance A. So again, these two in meters length and this distance A, they will get cancelled off. So let me just erase this. Okay, and I will get here mu 0 is proportional to F by I square, and that's exactly what I wanted here. So what I have is the unit for mu, which is nothing but magnetic permeability. So that was a nice one. Okay, so next one here is the initial tension on a stretched string is doubled, then the ratio of initial and final speeds of a transverse wave along the string. So this is very simple. We know the formula for tension, and velocity v is equal to root of t by m. It's the same string, so I can just say directly proportional to t. So what do they want is ratio of initial and final speed. So v1 by v2 is going to be root of t1 by t2. And what exactly is t2? Tension, initial tension is doubled. So t2 is 2 times t1. So it's 1 by root 2. Okay, 1 by root 2 is this one. Okay, and then the next one, in half wave rectification, if the input frequency is 60, what is the output frequency? This is again a very simple one. So what they are asking me is input is this one. Okay. The output is a half wave rectified. So I have positive half cycle, then nothing, then again positive half cycle, then nothing. Okay. So they are saying the output frequency is what? If the input is 60. So this is 60 hertz. Now this is repeating, this waveform is repeating after this much time interval, and this waveform is also repeating after the exact same time interval. So I should have the same frequency. Answer should be 60 hertz. Okay. Okay. So going ahead, we have here third one, third page. So this we already did. So yeah, this one was number 18. So this is question number 19 now. Okay. So the displacement time graphs, right? So displacement versus time of two moving particles make angles of 30 and 45 with the x-axis as shown. Ratio of the respective velocity. So what they are asking us is speed. So obviously I know velocity speed is distance upon time. So distance upon time is y by x. I have to talk about the slope. So what they want here is the ratio v1 by v2. So it's going to be tan theta 1 by tan theta 2. So who is 1 and who is 2? I guess let's take the 30-degree one as the first one. So tan 30 and tan 45 is 1. So tan 30 is nothing but 1 by root 3. So that is matching with this one. Okay. Okay, so the next one is they have given us a square loop of side 1 meter. Resistance is 1 ohm placed in a magnetic field. So B is given to us. They want a plane of the loop is perpendicular to the direction of the field. So if I have the loop like this, the field is going perpendicular to the plane. So they want the flux through the loop. So very simple, B is phi upon A, or phi is going to be B into A, and the angle is 0 between B bar and A bar, because the normal to the plane of the coil and the field are in the same direction. So it's simply B into A. The B value is given to us half, and the A value is area, so side square, so that is 1 square. So answer is half, 0.5 Weber. Okay, then shift this. Fine. The next one, energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour. So very simple. What is given to us is power is energy upon time. So energy would be power into time. So power is 100 kilowatts. So that is 10 raised to 3 plus 2 5. And what is the time? 1 hour. So they want in joules. So 60 minutes and 60 seconds. So I have 36 into 10 raised to 5, 6, 7. So that is this one. Okay. The next one, a body of mass 60 grams. So we can convert it to kilograms. So mass is 60 grams, 2 kilograms is 10 raised to minus 3 kg or 6 10 raised to minus 2. Experiences a gravitational force of 3 newtons when placed at a particular point. Okay. The magnitude of the gravitational field intensity. So they have given us the force is 3 newton. They want gravitational field intensity at that point. Okay, so we know the formula for field intensity, if I call it as E, right? Like for a charge, it is F by Q. So in this case, it's going to be F by M. So it's going to be 3 by what is the mass? 6 into 10 is 2. This was minus 3 plus 1 minus 2, which goes in the numerator becomes plus 2. So I got back, which is 0.5 into 10. So it's going to be 50. 50 is this one. Okay. Then the next one is match list 1 with list 2. So list 1 has electromagnetic waves and this is the wavelength. Okay. So this is, we'll have to recalculate of a guess. So AM radio waves, microwaves, this is very clear, microwaves, micro, right? They are micro. So it should be in micron, right? So infrared and X-rays. So definitely of the four, X-rays have a lot of energy. So X-rays should be very small wavelength or very high frequency. So it should be this one. Right? So D should be 1. And as you can see here, D1 is in 3 options. So this option is gone. Eliminate this one. Then they are saying, so I compare the options 2 to 4, which is 3, 4, 3, this is 4. Okay, so nothing is matching. So we need to guess. So X-ray is gone. X-ray is gone. Now infrared, microwaves and radio waves. Now radio waves, they have AM radio waves, right? Should be in a few megahertz. So if I consider megahertz as 10 raised to 6 hertz frequency. So then what should be the lambda value? So C is equal to nu lambda. So lambda should be C by nu. So C is 3 into 10 raised to 8 and this is 10 raised to 6. So I get 3 into 10 raised to 2. So 10 raised to 2 should be AM. So A should be 2, right? A should be 2 is only this one. So I think then this one should be the answer. Okay, and let's verify that with B and C as well. So microwaves and infrared. So B they are saying is third one, microwaves. Okay, so that's not 10 to minus 6. It's 2. Okay, so it can be in gigahertz. So the range is there. And infrared C is the fourth one, which is 10 to minus 4. Okay, is this correct? Because infrared is after red and red is 7500 angstroms, right? So infrared, let's say, is 10,000 angstroms. So if it is 10,000 angstroms, 10,000 angstroms, 10,000 is 10 raised to 4, angstrom is 10 raised to minus 10. So I get 10 raised to minus 6. Again, the closest number here would be not minus 10, it would be minus 4. So yes, C is the fourth one. That also makes sense. So I think then we have got our answer, the fourth one. Okay. So shell of mass m is initially at rest. Oh, initially at rest and then it explodes. So obviously the first thing that should come to your mind is law of conservation of linear momentum. So initial momentum is 0. It explodes into 3 fragments having mass in the ratio 2 is to 2 is to 1. So let's say shell is of mass m So how do I split it into 2 is to 2 is to 1? Um, let's say it splits into some mu. So 2 mu is to 2 mu is to mu, such that 2 mu plus 2 mu plus mu, because the total should be small m. I mean, I don't want to use capital M, so that's why I'm using mu for mass here. So what do I get? 2 plus 2, 4 plus 1, 5 times mu should be small m, or mu is nothing but m by 5. So basically, I have m by 5 and 2m by 5 and 2m by 5. That's the mass. Okay, fine. If the fragments having equal mass, they fly off along mutually perpendicular directions with speed v. Okay, so that's nice. One is going this way, one is going this way. So this is the equal mass is basically 2 mu, so 2m by 5. So 2m by 5 times v, and again 2m by 5 times v. And the speed of the third is what? Okay, so if these two have a momentum in this direction, the resultant is this way. So the third one should have in the opposite direction. So basically, what I will get is I just move this here. Oops. Yes. So this one. Okay. So I have in this direction root 2 times this 2mv by 5, and that should be equal to the third particle's momentum, because they should cancel each other, because the total has to be 0, because initially it was at rest. That's it. So the third one is having a mass of mu, which is m by 5. So I have m by 5 into some v dash. So these two are equal numbers. So mv dash by 5 is root 2 into 2mv by 5. So m5 is gone. So I have v dash is basically 2 root 2 times v. If that is an option, yes, that is 2 root 2v. Okay, next one. A biconvex lens has a radii of curvature 20 centimeter each. So it's equiconvex, biconvex. So 20 and minus 20 we can take. So refractive index of the material of the lens is 1.5. So that's mu. So power of the lens. So power is basically 1 upon f. And we know the formula is mu2 upon mu1. So in this case, let me just substitute the values. It's 1.5 upon 1 minus 1. So that's zero point 0.5 into 1 by r1 minus 1 by r2. That will become simply 1 by 20 plus 1 by 20 is 2 by 20. There is going to be positive power. But if you want power in diopters, then this focal length should be in centimeters. The radius of curvature should also be in, sorry, meters, not centimeters. So this 20 won't work. So we should say 10 raised to minus 2. Okay. So now we will get, so 1.5 minus 1 is 0.5, which is nothing but half, 2, and this is 2, and again 10 raised to minus 2 plus 1 is minus 1, which goes in the numerator becomes plus 1. So I have 10 by 2, which is 5, positive 5 diopters. Okay. Two statements are given to us. Statement 1, Biot-Savart's law gives us the expression for magnetic field strength of an infinitely small current element. Ideal, yes. Of a current carrying conductor only, yes, that's true. And Biot-Savart's law is analogous to Coulomb's inverse square law of charge Q, the formula being linked to field produced by a scalar source. Ideal, vector source Q. Coulomb's inverse square law of charge Q is basically 1 upon 4 pi epsilon naught Q1 Q2 by R square. So it's Biot-Savart's law analogous to Coulomb's law. Yes, that is also correct. And the former being related to field produced by a scalar source ideal, while vector source Q. Okay, fine. In light of the above statements, choose the most appropriate answer. So statement 1 and 2 both are right. Both are correct. Incorrect. Statement 1 is correct, statement is incorrect, and statement 1 is incorrect, and statement 2 is correct. So I think I will go with here the first option. Okay. In the given nuclear reaction, the element X is what? Oh, okay. This is again quite simple. So what is given to us? Sodium Na 1122. So what is this? New. Maybe doesn't seem to be like a particle gamma. Gamma. I think this is gamma. not mu, looks like gamma. So this is simply energy, so ignore this. E plus is a positron. Okay, so positron means where does a positron come from? Neutron has sorry, a proton has split into a neutron and a positron. So the number of proton has gone down by 1, and the A has remained the same. So I will get 22, but the atomic number went down by 1. So is there a 1022 somewhere? Yes, there is. Plane angle and solid angle. So what are they? Plane angle is your what we measure in degrees, and solid angle is what you measure in steradians. So they are our supplementary units. So I don't think so. They have any dimensions, units, but no dimensions, dimensions, but no units, no units, and no. They definitely have a unit. Angle, yeah, supplementary unit. So we'll just go with the first one here. Okay. So let's go to the next one now. Okay. So question number 29. They are saying the angle between electric lines of force and equipotential surface. So basically, what's an equipotential surface? Surface where the potential is equal. So if I consider, say, a uniform field, so the field lines are like this. Equipotential surface is going to be perpendicular to the lines of force. The angle has to be, I think, 90 degrees. Okay, a light ray falls on a glass surface of refractive index, so mu is given at an angle of 60 degrees. So what can we say? This is air, glass, ray of light falls at 60 degrees, and the refractive index is √3. So the angle between the refracted and reflected ray is like this, and there is reflection. So they want the angle. So I think we should check for IP, right? If mu is √3, so mu is tan IP. So mu is tan IP. So IP is tan inverse of mu. Let me write it here. IP is going to be tan inverse of mu. So tan inverse of what's the mu value again? √3. So IP will turn out to be tan inverse of √3 means 60 degrees. So this is the polarizing angle, right? So that means this angle is 90 degrees. Because if you sit and use Snell's law, it will waste a lot of time. Okay. Next one, PN junction is given to me. So PN in series. So this is a diode. This is another diode. They are in series, and then it has been connected to a cell, and it is forward biased, P positive and negative. Again, I have two diodes, but they are in series. But you see the N are like joined together. So this one may be forward biased, but this one is not. So this is going to act as an open circuit. And here current will flow. Here no current will flow. And again, this is NP. Again, so here current will flow. So in the given circuit ABC, so this is nothing but a mirror image of this one. So these both are kind of the same actually. If I see this circuit from behind, it will be this one. So in the given circuit ABC, the potential drop across the two PN junctions are equal in what? So here in this one, this is open circuit, and this one is a closed switch. So obviously the potential drops are not the same, right? Because here the entire voltage will appear here, and this is like almost 0 volts. So then I will go with A and C, both circuits A and C. Okay. Fine. Next one, a spherical ball, always spherical, is dropped in a long column of highly viscous liquid. Oh, so this is our terminal velocity. So curve in the graph shown, which represents the speed of the ball as a function of time. So initially, the speed will increase because it is accelerating, and then it should become constant. So there's only one graph here where it becomes constant, and that is this graph. And this one is D, this one is C, this one is A. So I think it's B one then. This one is B. It is this graph, but we need to make sure that we are selecting the right letter. Right? This straight line is for A, this is for C, this is for D. So this one. Okay. Two resistors of resistance 100 ohm and 200 ohms are connected in parallel in electrical circuit. So 100 parallel 200 there. Ratio of thermal energy developed in 100 ohm to that in 200 ohm in a given time. Okay. So I have two resistors in parallel. Voltage is the same, 100 ohms. It's 200 ohms. They want thermal energy. Basically, they're talking about heat. So I can use V square by R into T. So in a given time, so given time means T is constant, R is not constant. Parallel mein voltage is constant, so I have H inversely proportional to R. So if they want what the ratio, right? So H1 by H2 is going to be R2 by R1. So should I say 100 to 200? So this will be 200, 200. So it's nothing but 2 is to 1. Okay. Okay, let us look at this question now. Two monochromatic lights of frequencies nu and nu by 2. So we have our photoelectric equation. E times stopping potential is h nu minus h nu naught. So they are telling me that first frequency is nu and the second one is nu by 2. So second one is h nu by 2 and our function remains the same, h nu naught. And first case the stopping potential is Vs by 2 and second case the stopping potential is simply Vs. Okay, so what is the threshold? So what can we do here? We want to eliminate Vs because the answer is in terms of nu, right? So if I want to eliminate Vs, what I can do is divide this equation by 2. So I will get by 4 and this by 2. So if I subtract now, I'll get this as 0. I'll get this as h nu minus h nu by 4. So 1 minus 1 by 4 is 3 by 4 h nu. And here I will get h nu naught. Let's take the plus sign. H nu naught common. So I have minus 1 plus half, which will give me minus half. So I will get 3h nu by 4 is, if this whole term goes on the other side, I'll get 1 minus half, which is half h nu naught by 2. So h gets cancelled off. We have 2 2s are, so here nu is equal to 2 by 3, 2/3 of nu naught. So 2/3 of, oh sorry, we want it the other way around. We want nu naught. It is going to be 3 by 2 times nu. So is there an option 3 by 2 nu? Yes, that is this one. But still, if you have a close look at this equation again, so let me go back to the original equation. Um, what were we dividing? This one we were dividing by 2. Right? So we had the first one as nu and second one is nu by 2. So this is nu by 2. And the first one was Vs by 2 and this is Vs. So this here, there is something wrong in the number. I mean, we have solved it and got the answer, but this question itself seems to be a little bit fishy, because if I'm reducing the packet size here, if h nu is becoming h nu by 2, so let's take a number. Suppose if this is 5 eV and this is 2 eV. Okay, so how much Vs will I get? I will get a Vs of 5 minus 2, 3. So Vs by 2 is 3, that means Vs is 6. So am I getting 6 here? Let's check. So if I'm dividing by 2, I'm dividing 5 by 2, so I have 2.5, and here I have the same number 2, so I'm getting only 2.5 minus 2 is 0.5. So these numbers itself, right, these numbers what they have given are wrong actually. This question is wrong, but using the wrong data if you want to solve it, this is the answer, 3 by 2 nu. Okay, fine. Next one, if a soap bubble expands, the pressure inside the bubble, what will happen to the pressure inside the bubble? Soap bubble expands, so Pi minus PO, so let's take the minus P on the other side, it becomes plus PO, is soap bubble hai to we have to say 4T by R. Now the pressure inside, what will happen to the pressure inside if the soap bubble expands? So pressure outside is the same, air pressure. Okay? So what is happening is the radius is increasing, because the slope bubble is expanding. So this term is reducing. So I'm adding now a smaller number to P naught. So pressure inside now is going to reduce. It's going to decrease compared to before. Earlier it was P naught plus a bigger number. Now I have P naught plus a smaller number. So the value has ultimately gone down. Okay. So pressure inside has decreased. Or if you just want to say simple relation, Pi is inversely proportional to R. R बढ़ गया तो P कम हो गया. Fine. So we are now in section B. So 2-point charges minus Q and plus Q are placed at a distance L. So this is a dipole, right? They want the magnitude of electric field intensity at a distance capital R, which is very large compared to L, but they have not told me axis है कि equator है. So we'll just take it at some random distance, at angle theta, right? Random distance R at some angle theta. So the formula here is that your electric field intensity, is nothing but 1 upon 4 pi epsilon naught. So that's a constant. P, which is Q into L, is again a constant, by R cube, right? So in this case, it will be capital R cube because that's my distance. And root of 1 plus 3 cos square theta. So whatever is theta, it doesn't matter, right? So let theta be some constant. So I have inversely proportional to R cube. Now, if this R is very large compared to L, does it matter? We have P in the numerator actually. P in the numerator, P is Q into L. Right? Q into 2L, but in this case, that 2L value here is L. Right? So I have L by R cube, but anyways, L is negligible. So I think I can just go with this one. Okay. Fine. So we can move on to the next page. Okay. So going ahead. Okay, so the next one here is the area of a rectangular field in meter square. What field? Significant digit. Okay, so they are just talking about a rectangle. So area is given to us of length 55.3 meters and breadth 25 meters. After rounding off, the value for correct significant digits is what? So basically we have to multiply these two numbers, 55.3 into 25. So what would that be? It's a simple calculation. So 55.3, or let's say 55 plus 0.3 times 25, or let's say 50 plus 5 plus 0.3. So 25 into 5 is 125, add a 0. 25 into 5 is 125. And 25 into 3 is 75, but I have 0.3, so 7.5. So add these numbers into 125, and this is 7.5. So 12, 8, 1382.5, and they are asking us, after rounding off the value for correct significant digits. So 55.3, right? So this is from the first chapter, right? So we have this number 138. Now correct significant digits. So how many significant digits here we have? We have 0.3. So decimal के बाद एक digit चलेगा. So then this only, because decimal के पहले कितना भी number हो, that's fine. So this 0.5 should be valid, right? 138.2.5. So I guess we can go with this number. We can check more on this using the first chapter. So very rare kind of question to be asked in NEET actually. Very, very silly one, but we just need to check the rules again for significant digits. Okay. Anyways, this is a logic gate. So we have A here. So what do they want? Truth table they want. Okay, fine. So we have A and B as the inputs. So we have A, and this is not A, so A bar. and this is B, and this is B again. So the first one is a NAND gate. So it is multiply the two, that is A into B, and then not of that. And this is again a NAND gate. So multiply these two, A bar and B, and not of that. Okay, so what is not of A bar dot B? So this is going to be A bar bar, which is A, plus B bar. And this one is going to be A bar plus B bar. This is A plus B bar, and this is A bar plus B bar. And now I am multiplying these two again. So I have A bar. So let me write it here actually. So I have A bar plus B bar multiplied with A plus B bar. So what do we get? So we have A bar into A plus A bar into B bar plus B bar into A plus B bar into B. Now what is A bar into A? So because if A is 0, then A bar is 1. So 1 into 0, and the same thing here, 1 into 0 will always give me 0. So these two terms are gone. Ignore these two. So I have this basically. These two terms are left. So A bar B bar plus AB bar. So it's like this. I can write it as A bar B bar plus AB bar. So let me take B bar common. I left A bar plus A. So if this is 0 and this is 1, right? Because not of 0 is 1, or either way around, 1 and 0. If I add the two, I'm always going to get 1. So this is B bar, okay, into 1, which is always B bar. So the answer is, the output is B bar. So B bar, so whatever is B, उसका opposite होना चाहिए. 0 1 0 1 0. No, this is not true. 0 1 0. So this is 1 0 0. This is also not true. 0 1 0 1. This is 1 0 1 0. This is and this is the same as B. So we want B bar, right? We want B bar, opposite of B. So it is this option. 1 0 1 0. Okay, fine. Next one. They're saying given below are two statements. One is labeled as assertion A and the other is labeled as reason. Okay, fine. Stretching of a spring is determined by the shear modulus of the material of the spring. Yeah, in one sense, because shear modulus means the one related to shape, modulus of rigidity, not the bulk modulus, not Young's modulus. And yes, the shape of the spring is changing when I stretch it or compress it. So yes, I agree. And a coil spring, what's a coil spring? Coil spring is like this, it's like a coil. Springs like this. So coil spring of copper has more tensile strength than a steel spring. A steel spring means a normal spring like this, which has more tensile strength of the same dimensions. No, I think here what they are talking about is not the shape. They are just saying coil spring and steel spring. So I think what they are talking about is the copper and the steel here, the material. So one is copper, other one is steel. So who has more tensile strength? I think I will go with steel. Steel has more tensile strength. In the above light of the above statements, choose the most appropriate answer. So, एक minute. Coil spring has more tensile. So reason is wrong actually. Steel spring has more tensile strength, and obviously this reason has nothing to do with this A, right? Shape say, oh yeah, modulus of rigidity. कुछ लेना देना नहीं है. So A is right, R is wrong. So both A and R are true. No, both are true. A is true, R is false. Yes, this one. Third one. We'll go with the third one. Okay. Now from Ampere's circuital law, okay, for a long straight wire, Ampere's circuital law. Let me take a look. For circular cross section carrying a steady current, right? Steady current I. The variation of magnetic field inside and outside region of the wire. Oh, so what's the magnetic field inside? Right, inside is the solid material. Right? So this is like my wire. So what is the magnetic field inside and what's the magnetic field outside? So magnetic field outside, we know the formula B for a straight wire is mu 0 I by 2 pi A, where A is the distance. And if you want magnetic field inside, then it is inside the thickness of the wire. Right? So for a solid cylinder, it is directly proportional to small r, the distance. So inside, be inside, I will say, different color. see this one. B inside is proportional to the distance, and B outside is obviously inversely proportional to the distance, R or A, whatever you want to call it as. So let's check this out now. Uniform is uniform and remains constant for both the regions. Obviously, no. It changes with distance. How is it the same? It doesn't remain constant. A linearly increasing function of distance up to the boundary, yes, because it's directly proportional. And then linearly decreasing. It's not linearly decreasing. Linearly decreasing means the graph is like this. It's not like this, because the inverse graph is supposed to be like this. So I'll put this one on hold. A linearly increasing function of distance r, yes, and then decreasing one with 1 by r dependence for the outside, yes. This is the one. Third one is the answer. Linearly decreasing function, no. So I will go with number 3. 41. Series LCR circuit with inductance 10 Henry. Okay. This is L. C, R connected to an AC source of voltage. If the resonant frequency is mu naught and the frequency of the AC source is nu, then what's nu and what is nu naught, they are asking. Okay, so what's nu? So this is omega t, 100t. So omega, which is 2 pi f, is 100. So what's f? 100 by 2 pi, or it is 50 upon pi. So nu is the frequency of the AC source. So it's 50 upon pi. So that is this one. Oh, it's not 100 upon pi. So that's it. I've got my answer. Still, you want to verify nu naught, which is the resonant frequency. So that formula is going to be what? Nu naught, or anything nu naught. We call it as f naught, right? Or whatever you want to call it as, is going to be 1 upon 2 pi root LC. Okay, now what is root of LNC? Root of 10 into what do you say? 10 micro. So micro is minus 6 plus 1 is minus 5. So 10 into 10 is to minus 5. So that will give me 10 is to minus 4 ka root is minus 2, upar gaya to plus 2 by 2 pi. So again that is 50 by pi, and that's matching with this one. So yes, they both are 50 by pi. 42, match. Again, that's the column. Usually they don't give this kind of, it's like new in this paper. A lot of these kind of questions, theory related questions. Okay, so match G potential energy. This is a universal gravitational constant. This is potential energy. So this is simply, you can say MGH. Gravitational potential and intensity. So I think let's begin with this one. The B1 is the easiest to find. And as you can see, the B in all, I mean, these two options are the same. So at least we can eliminate two options, right? So potential energy, whether I take it as MGH or whether I go by the original formula, it's the same. So in G, dimension is the same. So kg, G is meters per second square, and H is again in meters. So I have kg meter square per second square. So I will go with M, or if they are starting with L, sometimes L is L. Okay. So M raised to 1, L raised to 2, and T raised to minus 2. So is there an option like this? M1, L2, T minus 2. Right. So D is definitely 4. So D is 4. So that eliminates this option and this option. I think that was pretty obvious. B is 4. Now, what should I check? Next one, the easiest one to check would be A, G, but that also I don't need to check because it is 2. So, but 2 is gone. This is done. So now, what is the difference here is between C and D. So, which is gravitational potential and gravitational intensity. Both are easy to find. Let's just find out potential, because this potential energy is potential into mass, or let's say V. So potential would be potential energy upon mass. So all I have to do is divide this by mass. So I have meter square per second square. That's it. So L2 T minus 2. So L2 T minus 2 is this one. So that's it. Gravitational potential is this one. So C should be the first one. C is the first one. That means this is the answer. Okay. Next page, the last page. Okay, so Okay, so let's begin this one. Um, Two pendulums of length 121 and 100 centimeters. They start vibrating in phase. Okay, at some instant, the two are at their mean position in the same phase. Fine. And the minimum number of vibrations of the shorter pendulum, after which the two are again in phase at the mean position. So we know that the time period t is 2 pi root of L by G, or I can just say here proportional to root of L. So T1 by T2 is going to be root of L1 by L2. So 121 by 100, both are in centi. So root of 121 is 11. This is 10. So their time periods are this, or their frequencies are 10 by 11, whatever you want to call it as. Okay. So now the ratio of the frequency, right, N1 by N2. Okay, interfere with the next question. Yes. So N1 by N2 would be 10 by 11. So in 1 second, like in hertz, if you say, right? So anyways, not exactly in 1 second, but you can say N1 is like the first one is having 10 oscillations and the second one is having 11 oscillations. So they want the minimum number of vibrations of the shorter pendulum. So who is shorter here? The shorter one is the 100 centimeter ones, that is the second one, right? So oscillations of the second one, how many they should be? 11 oscillations. So I think we can go with the first option. Okay, fine. Then the next one is a big circular coil of 1000 tons. The number of tons is given to us. Average radius is given, is rotating about its horizontal diameter. Okay, so the coil rotating about horizontal diameter like this. Okay, at 2 radians per second, so that omega is given to us. N is given, radius is given, omega is given. Vertical component of Earth's magnetic field at that place, so BV is given. Electrical resistance of the coil is given. Maximum induced current in the coil will be how much? The maximum induced current, right? So do we know what is the maximum induced voltage here? Right, because it will be a sinusoidally varying voltage. Why? Because it's a rotating. It's basically, this is your generator, AC generator. So if we know E is E naught sin omega t, that E naught value is NAB omega. So they want I naught, so it is I naught into R. So the maximum here is simply NAB omega upon R. That's all I have to do. N is 10 is to 3, area is pi into radius square, radius is 10. So 10 square, 10 is to 2. B is 2 into 10 raised to minus 5. Omega is 2. And this is our resistance is 12.56. Now this 3 plus 2 is 5 and minus 5 get cancelled off. 2 to the 4 pi. And 4 pi is almost 12 point something, and this is also 12 point something. So this should turn out to be 1 ampere. Alright, the next one is on a capacitor. Capacitor of capacitance 900 picofarad, which is, I guess, this one, is charged fully by 100-volt battery. Okay, as shown in the figure A. Fine. Then it is disconnected from the battery and connected to another uncharged capacitor of the capacitance 900 pico. Same as shown in the figure B. So the electrostatic energy stored by the system B. How much energy is there in B? So we have a formula, direct formula for loss of energy. Right? So if we just add that loss of energy to our energy in this case, right? So that will give me, actually subtract. They want energy in this one. So subtract that from the energy in this case, and that should give me the answer. Okay. So energy in the second case, let's call it as E, E2, is E1 minus the loss. Okay. What is E1? Half CV square. And what is the formula for loss of energy is C1 C2, which in this case are the same. So C1 C2 is going to be C square upon 2 times C1 plus C2, which is 2c into V1 minus V2 square. Okay. So V1 is now this voltage 100 volts. Right? The first capacitor is charged to 100 volts, and the second capacitor is not charged at all. It was 0 volts, right? Uncharged capacitor. So V1 minus V2 square is nothing but here is going to be V square. V square. So that's it. I have C and C gets cancelled off. So I have CV square common. I have 1 by 2 minus. So I have C and V square here. And instead of 1 by 2, I have 1 by 4 here. So 1 by 2 minus 1 by 4 is 1 by 4. So answer is CV square by 4. So now I need to calculate this. So CV square by 4. So C was 900 pico. So 9 into 10 is to 2. Nano pico is minus 12. Nano is minus 9. Pico is minus 12. Right? Kilo, milli, mega, micro, giga, nano, mega, pico. So 12. And V square. What was the voltage again? It was 100 volts. So 100 square is 10 to 4 by 4. So that is going to be 9 by 4. So 9 by 2 is 4.5 divided by 4 is how much? 1.1 something. And I have 10 raised to what is it now? 4 plus 2 6, and minus 12 is minus 6, so that's microjoule. So everything is in minus 6, so that's not a problem. 1.1 something something. So I think the closest option here I would go with is number 4. Okay, fine. So 46, a nucleus of mass number 189. So that is my A. Splits into two nuclei having mass number 12564. The ratio of radius of two daughter nuclei. So all they want is ratio of the nucleus, right? So how will we get that? We have a formula for this one. Radius of nucleus. Radius of nucleus is R0 a raised to 1 by 3, correct? So let's say R1 by R2 is going to be R0 is a constant. So daughter 1 has 125A. Daughter number 2 is A value is 64 and cube root of this whole thing. So 125 is whose cube? 5 cube. So and this is 4 cube. 4 for the 16 for the 64, 5 for the 25 for the 125. So cube and then 1 by 3. So I have 5 by 4. That's it. It's very easy. Which stone finally is used to determine the value of unknown resistance X, okay, by adjusting the variable resistance Y. Okay. For the most precise measurement of X, the resistance P and Q should be approximately, actually, if you want a precise value, then your null point should be somewhere in the midpoint. That means they will be in the midpoint if P and X are equal or Q and Y are equal. So ratio of left right, or actually the ratio of top bottom should also be the same. So P and Q should be equal then, approximately equal to 2x. No, approximately equal and are small. No, small and large is okay. Should be very large and unequal. No, do not play. No, I think approximately equal and small is fine. Yeah. Why not the first one? Because why should it be 2x? Yeah. I mean, it's fine if they both are 2x. You know, they will still give me ratio 1:1. But then this is 2x and this is x. And the problem is I will get a ratio 2:1, and then my null point will not be in the middle. So if I want the null point in the middle, this is the best option. It should be equal and not very large. It should be x or y range. Okay, so the volume occupied by molecules contained in 4.5 kg water at STP if the intermolecular forces vanish away. Okay, so this one is related to your gas equation. So what they are trying to do here is they are trying to confuse you with Van der Waals equation for real gases, right? I mean, anyways, it's not a gas; it's actually water. So, I mean, even if it was a gas, then I would think of the intermolecular forces, and because of that, the volume, actual volume is slightly less, and because of that, we take V minus NB as the volume. But we don't have to do all that, it's just simply water. So, all I should do is density is mass upon volume. So if I want the volume, it's mass upon density, and the mass of water is 4.5 kg, and STP standard pressure. So, density, let's take 10 is to 3. Okay? So that's it, 4.5 10 raised to minus 3. Now there is only one option here which is of the order of 10 raised to minus 3, and that is this one. Now why that number 4.5 is not coming? Instead of 4.5 they are taking 5.6, so that may be due to something because of the intermolecular forces. But anyways, if I just simply go by the order of magnitude, it should be 10 raised to minus 3. Okay, the next one, a ball is projected with a velocity 10 meters per second, so that is u, and angle is 60, so that's my theta. With the vertical, oh, theta is 60 with the vertical, but we take it with the horizontal, so theta now I'm going to take it as 30 degrees. U is 10. Speed at the highest point of its trajectory, oh, this is very simple, it's going to be u cos theta, and the horizontal highest point is simply the horizontal component. U cos theta, so I'm going to get 10 cos 30, which is sin 60, which is root 3 by 2. So answer is 5 root 3. Okay. And then the last one. So two transparent media A and B are separated by a plane boundary. Speed of light in those media are 1.5 and 2. So wait, is denser, is rarer. Speed of light is faster in a rarer medium. So let's say this is 2, rarer is faster. We are rarer, denser. And the denser one is slow. So this is glass actually. 10 is to 8. Or actually, yeah, I mean, whatever, some rarer denser medium. So now they want critical angle. So very nice. So critical angle is sin IC. Okay. So sin IC is 1 by mu, but assuming this mu is of denser with respect to rarer. So I'm going to get mu of denser, mu 2 by mu 1. But mu 2 by mu 1 is nothing but V1 by V2. So V1 by V2 is mu 2 by 1. So this is mu r के बदले V denser and I should have V rarer. So denser का क्या है भाई 1.58 understood, and this is 2, so that's it, 1520 or 5 3s are 4s are, so 3 by 4 is 0.75, so sine inverse of 0.750, and that's the end of your paper.